Welcome to section 7.2. We're dealing with exponential decay. This lesson is going to be very similar to what we did in section 7.1. But I want to start off at the top by putting in some information. We knew that the exponential equation was y equals a times b to the x. Okay, and we did that in lesson 7.1. When it was growth, we said that our b value here had to be bigger than 1. But with decay, we need b between 0 and 1. Okay, so you're talking a fraction or a decimal, and we're going to show you today more in fraction form. But what's important is that the base of the exponent has to be between 0 and 1 in order for it to be exponential decay. We also want to talk about the general equation and what our shifts do, like we did in section 7.1. So let's go through this again. We have a times b to the x minus h plus k. Okay, and we talked about yesterday about what each does. So let's go back through that again. Let's start with a. A has three main purposes. If a is greater than 1, then we have a stretch. If a is between 0 and 1, then we have a shrink. And if the value of a is less than 0, then we have a reflection over the x-axis. Now I want to go back up and actually modify this a little bit. In this, I want to say the absolute value of a, because a really has two parts when it's negative. It does a stretch and it does a reflection, and so I kind of want to make that distinction. We also had h, and h tells us to move either left or right, but the important part of that is it's always the opposite. And so we talked about in 7.1 that if it's a minus h, you're actually moving to the right. If it's a plus h, you're actually moving to the left. And k is going to tell you if you move up or down. And this also affects our asymptote we talked about yesterday as well. So we want to get that idea in as we go through. And so I'm going to start the examples with you like we did in section 7.1, and I'm going to give you a couple of questions to do before you come into class. And so I'm going to start with example 1. And like before, if we didn't have an a value, I'm going to throw a 1 in front there, 1 times this. Because my goal is to figure out what that a value does for my y-intercept. We said yesterday, let's start making a table, and we'll talk about, again, reiterate one more time where that y-intercept comes from. We said in exponential functions, let's use our trusty -2, -1, 0, 1, and 2. And these are exponents. Again, if you have your graphing calculators, you can put this in your y equals menu. Otherwise, let's use our exponent rules. Now I'm going to start with 0 because anything to the 0 power is always 1. 1/5 to the first power is 1/5. 1/5 to the second power is 1 to the second, which is 1, over 5 to the second, which is 25. We said negative exponents take reciprocals. So to the negative first power is the reciprocal of the first power, so just 5. And the negative second exponent is the reciprocal of the second power, so just 25. And we're going to take this and we're going to put it on our graph. So let's go with some nice points. -1, 5, 0, 1. 1/5 is about 0.2. 1/25 is really close to 0. And I'm going to kind of curve this around, and we end up getting, don't forget your arrows, a exponential decay function. And you'll notice the decay looks slightly different than it did yesterday. Growth started really close to the x-axis and got bigger. Decay starts really big and gets closer to the x-axis. Okay, now let's fill in some information. My y-intercept is when x equals 0. So my y-intercept occurs at the point 0, 1, and that 1 comes from the number that's in front of the 1/5. My asymptote is the x-axis, so I can draw in that dotted line. My asymptote is the x-axis, which is the y equals 0 line. In this case, there's no left or right shift or an up or down shift or an a value that's anything other than 1. So there is no transformation. If you look my domain, we ask ourselves, can we do a negative? Yes. Can we do a positive? Yes. Can we do 0? Yes. So my domain is all reals. And my range, if you look at where my graph is above my asymptote, so we say all reals greater than 0. And that's the first one we're going to look at. Okay? Let me actually move this down, and let's do example 2. And we're going to do examples 2 and 3 together, and then I'm going to have you do example 4 on your own. But let's look at example 2. Take a look at this value of 3. That is the value of our y-intercept. So I should automatically be able to go and plot to the point 0, 3. The second thing I want you to get in your mind is that I don't have anything back here to tell me that I'm moving up or down. And if I'm not moving up or down, then my asymptote will still be the x-axis. So I should automatically be able to say that y equals 0 is my asymptote. What I also want you to be able to say is, because this point is stretched farther away from the asymptote, I should be able to tell automatically that that 3 says I have a stretch of 3. And because it's away from the asymptote, we call that a stretch. Truthfully, I would like you to be able to tell me domain and range too before you get much farther. You'll notice any exponential, I can have all reals for my domain. I'm always going to be able to put in negatives and positives and 0. And lastly, you'll notice this point 0, 3 is above my asymptote. And if it's above my asymptote, then my graph will be above my asymptote. So all reals greater than 0, because 0 is where my asymptote is. And I want you to be able to get in the habit of filling these out before you even have to do a lot with your graph. Now for the rest of the graph, we might need a table, or you can stick this in your y equals menu and do that as well, like we did in class yesterday. If you don't have the y equals menu, or you don't have a grapher, then we come back to our table where we say -2, -1, 0, 1, and 2. And I'm going to do the same thing I did before. I take my base to my exponent. So 2/3 to the 0 power is 1, and 1 times 3 makes 3. And I should be able to fill that in anyways because I know it's my y-intercept. But let's do the first power. 2/3 to the first power is 2/3. 2/3 times 3 is 2. And I'm going to put that on my graph. Okay, let's do it again. 2/3 to the second power, you take 2 to the second power, which is 4, and I'm going to make a little note over here, 4, and 3 to the second power is 9, and I multiply that by 3, and I'm going to write 3 over 1, because I'm going to get 12 over 9, which reduces by 3 to 4 over 3, so 4/3. So 1.3 repeating is, or maybe right about here. Okay, we go backwards. The negative first power changes the 2/3 to be the reciprocal. So I'm going to move that up there. So I end up getting 3 times 3 halves, which is 3 over 1, 9 over 2. And if you want 4.5 as an acceptable decimal, I like 9 over 2 better, but I also understand that you're graphing this, so 4.5. You could do -2 as well, but if you notice, I'm not going to be able to get -2 on my graph. So I'm just going to curve this around, and I get this graph. Okay, and this is kind of the process we want you to take. I really would like you to get, if you can, get comfortable without your calculators. If you need your calculators to be able to get the points, that's okay too. We're going to do example 3 together, and then I'm going to have you do example 4 on your own. But let's look at example 3, this -2. Let's start first with the y-intercept. Okay, and I'm going to plot that right on my graph. Here's another thing. I'm not going up or down, so where's my asymptote? It still is at the x-axis, or the y=0 line. Because there's no value at the end to tell me to move it up or down, it's at the 0. If you look, my domain, any domain for an exponential is all reals. Let's talk about my range. My range, if you look at my value, is already underneath the asymptote. So to say below, I say all reals less than, and my asymptote occurs at 0, so I put a 0 there. And I'm going to describe my transformation. The negative says reflect over the x-axis. The 2 is its own separate thing. The 2, because it's bigger than 1, says a stretch of 2. And again, you'll notice normally my y-intercept is at the point 1. It's at 2, so it's stretching away from the asymptote. Okay, to plot the rest of the points, again, you could use your grapher or make a table. Either or, what I'm going to do is use my grapher a minute, and I'm just going to plot some points on here. You end up getting a value like 1, -1.5, 2, -1.25. You get these values like this. Something like this, and you end up getting this curve. Okay, don't forget the arrows at the end and also the points on your graph. But again, we should be able to do this, and I want you to get used to your calculator. So in class, if you're not quite sure how your calculator works, please let me know so that I can help with the calculator and how does it work and what do the things mean. Again, number 4, circle at start. This is on your own, and it must be done before coming to class. Okay, now I'm filling in all this space. You don't actually have to write this. I want you to do the work. But again, I want you to do example number 4, which is really a lot like example number 3, to be able to have a discussion of how did we do, how does it work, things like that. Okay? Now, I'm going to switch to my next page. Okay, and I want to go through that discussion again. Now here we make more changes. And so I want to do example number 1 with you, and I'll have you do example number 2 on your own. But I want to look at this. In example number 1, let's talk about, instead of the y-intercept, I'm going to change this to starting point, because I'm going to make some adjustments as we go through. And here's what I would suggest to you, is to describe the transformations before you actually start graphing. So here's what I'm going to do. This 2 in front says make a stretch of 2. The one at the back says move your graph up 1. The x minus 1 in the exponent is opposite of what we think. So not going left, we're actually going right 1. And these descriptions I would like you to be able to do, because I'm not going to always ask you to graph it. I'm sometimes going to say to you, just tell me what happened. Describe the transformation. Well, let's talk about starting point. Starting point is normally what we think of our y-intercept. And because the 2 is in front, my point would be 0, 2. The only problem is I'm going to take that and I'm going to move it right 1, and I'm also going to move it up 1. And so I'm not going to end with a point 0.02 on my graph. And so that's why I call it a starting point now. My asymptote changed. This plus 1 said move it up 1. So my asymptote is not going to be a y equals 0 anymore. It's going to be a y equals 1. So I'm going to slide that asymptote in. Okay, I'm also going to think about where my starting point would normally be 0, 2. I now have to move it right 1 and up 1. Here's the first point I'm going to graph. And so this is kind of the idea. Now from here I should be able to at least do domain and range. My domain for an exponential, no matter what I do, is always all reals. And if I look at the point, my point is above my asymptote. So my range is going to be all reals greater than, and because my asymptote is at 1, my range is going to be all reals greater than 1. Now, to get the rest of the points, you can do two things. You can graph the original, y equals 2 times 3/5 to the x, and then move each point up 1 and right 1. Or I would at this point in time go to my graphing calculator and stick that in my y equals and find the points from there. What you end up finding for points, and I'm just going to kind of approximate as we go through, you get 0, 4 point something at 2, 2.2 I think, 3, you end up getting, I'm trying to just approximate this a second, you end up getting something like this. And again, my graph won't touch my asymptote, so be careful of that. But you end up getting a decay graph because the 3/5 is less than 1. And so, again, I really want you to get used to and comfortable with your grapher, but if you're really feeling like, Mr. Panic, I don't have a grapher, how do I make this work? See me in class and we'll work together on that. Last thing on the graphing, for number 2 here, I would like you to do it on your own. I want to see that you can use your grapher or at least explain to me these things. But one thing I want to change, instead of a -3 times 1/2, let's make this a +3 times 1/2 to make it actually fit on this graph. Okay, so this is an on your own question. Have this done before you come to class. So that's number 2 that I want you to do for homework. The third thing we're looking at is exponential decay formula, and we gave you 2 formulas on yesterday's video. I'm only going to give you one today. Very similar to yesterday's. We go y equals a times 1 minus r to the t. Let's run through what these are again. A is your initial amount. Okay. R is your rate. Don't forget it's got to be as a decimal. And t is time. Okay, so I'm going to do example 1 with you and help you set up 2A, have you do 2B on your own. But take a look at this. A new TV costs $1,200 when you purchase it. That is my A value. The value of the TV decreases. That means do 1 minus by 21%. Now I need to take the 21%, and we talked yesterday, divide by 100, and you'll get a decimal of 0.21. And that's my R value. Write a general equation. So my equation is going to say this. I started with 1,200. I do 1 minus 0.21 to the t. Okay, now your book, I just want to have one quick discussion. Your book writes it like this, 1,200 times 0.79 to the t. Are these the equivalent? Yes. What they said is I don't want to see plus or minus in a base, so I'm just going to actually subtract them and get 0.79. I would be okay with either of these. It's kind of up to you. Okay. Example 2 says you purchase a 2010 Honda Civic. Let's put an amount in here for $10,000. Car depreciates, that means subtract in value each year by 2.35%. Again, divide that by 100, you get 0.0235. That's our R value. 10,000 is our A value. Let's write an equation. We paid $10,000 for our Honda. 1 minus 0.0235, because that's our rate, to the t. What I would like you to do is figure out how much it's worth in 8 years. So there's number 3 to do on your own. So 3 things tonight that we want to work on. bring them into class tomorrow. That's what we're going to start the day with, is checking those 3 questions. And truthfully, you will not get full points for doing the notes until those 3 are completely done. Okay? That's the end of section 7-2. Again, if you 3 questions before you come to class. If you get a chance to start your homework early, that'd be great. If not, we'll work on it in class.